Welcome to this session on real data, traceability for greenhouse gas emissions. I think to those of you here in the room in Davos, but also those who are joining us online as a live stream session here. My name is Antonia Gawel. I head climate change at the World Economic Forum, and it's definitely a pleasure to be here with you all today. Now, of course, I've hoped that you've seen that climate change is really a central focus for conversations this week here in Davos. One, because we know that the science tells us that it is absolutely critical that we not only tackle climate change, but also that we restore, protect, preserve the ecosystems that are so connected to achieving that objective as well. And this is a precondition, not a necessity, a precondition to achieving livelihoods, to having thriving economies as well. So this system connection is so fundamental, which is really why we're so focused on this topic. I think today, what we'll also see is that technology and data, but also partnership and collaboration is really what we need to get there. And that's what we hope to hear about and to discuss in this session as well. Now, it is, of course, my honor to introduce the Honorable Al Gore, who over the next 15 minutes will delve into the new frontier of emissions tracking with Climate Trace. Of course, following decades as a dedicated legislator and 8 years as Vice President of the United States, Mr. Gore was also jointly awarded in 2007 the Nobel Peace Prize alongside the United Nations Intergovernmental Panel on Climate Change for the amazing work that he and they have done to really raise awareness on this critical topic. Now, in addition to that, your best-selling book and film, Inconvenient Truth, really launched this topic into the mainstream. I watched that film and it certainly influenced the way that I thought and communicated about climate change as well. Now, since that time, over the past 15 years, I think as a member of our Board of Trustees, you have really driven this topic throughout everything that you do. You work with youth, you drive transparency, accountability, and collaboration to really push forward climate action. So thank you, Vice President Gore, for your incredible leadership. And I will now turn it over to you.
Thank you very much, Antonia. Thank you for the work that you do and that you and your colleagues do here at the WEF. And thank you all very much for coming. I'm going to zip through this presentation because I always start by setting the context. This is the famous Earthrise picture from the first mission that went far enough out in space to see the Earth floating whole. And this is the famous blue marble that was taken on the last Apollo mission. It sets the context for a discussion of how to track the emissions that are causing the climate crisis. I usually start with a lot of images that illustrate all the horrible damage that's being done around the world. I've only selected eight or 10 of them here. I used to go back, years ago there was this, decades ago there was this. I can do it just last week now, or yesterday. And actually in California, this is an atmospheric river from Hawaii, 2,500 kilometers to California. And this is the moisture that it contains. And the reason it contains that much moisture is that we're trapping as much extra heat with the greenhouse gases as would be released by 600,000 Hiroshima-class atomic bombs exploding every 24 hours on the Earth. And 93% of it goes into the ocean, and it's boiling the oceans. That's a metaphorical phrase, but it's not far off. And the water vapor is increasing quite dramatically, and so these atmospheric rivers are much larger now, and you get these rain bombs. And for the last 2 weeks, California has been lashed by these. And just yesterday, this morning in the southern Philippines, they have a similar event. Last year at the COP, at the UN, the Secretary General talked about some of the damages caused by the climate crisis last year. The flooding in Pakistan was of biblical proportions, maybe I should say Quranic proportions, really unbelievable, and 10% of their GDP was lost in this flood. Didn't get as much attention, but a massive flooding event in Nigeria displaced 1.5 million people, and in Congo just last month. So the heat wave around the world, this past summer was the hottest in Europe. Here in Switzerland, it was the hottest year ever recorded in history, along with all these other countries, Germany, China, etc. And speaking of China, the heat wave in China was the hottest, worst heat wave in recorded history. And the historians say that there is nothing even minimally comparable to what happened in China last year. And in addition to disrupting the water cycle with these atmospheric rivers and rain bombs, it sucks the moisture out of the land, and you get droughts simultaneously. This is one of the rivers in China, and many of the great rivers, the Tigris, Euphrates. In the southwestern United States, this is now being called the Millennium Drought. And of course, the food consequences are very dire. The war in Ukraine, the evil invasion of Ukraine by Russia has worsened these, but they were already there because of the climate crisis. So we live on an earth that is under siege, and it's costing an increasing amount each year. In the last decade, $2.5 trillion, an increase of $1 trillion over the previous 10 years. In the annual report put out by the WEF here in Davos each year, the greatest threat to the global economy is the climate crisis. So what if we could see, when we look, this is a video of the Earth from 1 million miles out toward the sun, 1.5 million kilometers. What if we could see exactly where the greenhouse gas pollution is coming from? There's an old saying that you can only manage what you can measure. Well, we can now. Each one of these spikes is a source of greenhouse gas pollution. These are the largest sources around the world. Climate Trace has produced this. Climate Trace is a coalition of 11 organizations. It's a nonprofit coalition that uses artificial intelligence to process data from 300 existing satellites and from 30,000 land, sea, and air-based sensors and multiple internet data streams to use artificial intelligence to create machine learning algorithms to zoom in on every single significant source of greenhouse gas pollution. Here are the members of the coalition. It's weird they put my name there. That's a team of people that works for me in Nashville, but the others do the heavy lifting. And it's a coalition, and it's really fun to work with these smart people. We also have 100 other organizations and researchers who are contributing. Will Marshall is the CEO of Planet Labs. You'll see Planet Labs come up here along with some of the other satellite companies. Will has done a terrific job, and I appreciate all of the help. Will, we also get ground truthing information from some companies that monitor their own greenhouse gas emissions. We don't use it except for ground truthing, because with machine learning algorithms, you can fine-tune them and make them more and more accurate. Robert Ugla, the head of Maersk, is here, and Maersk immediately said, yes, absolutely, Al, we'll help you. They give us, they do it like every 10 minutes, not only every ship, but every boiler on every ship, and thank you, Robert. There are many others. Mahendra Singh is around here from Dalmia Cement. There are many, many of them. ArcelorMittal, there are many of them. So thank you to all of them. So what we produced is a complete inventory of greenhouse gas emissions from every country in the world, 194, plus territories, adding up to 241 in every major sector. And we identified the largest individual emission sources in subsectors as well, and we have data not only on CO2, but CO2 equivalents, methane, nitrogen oxide emissions, and we do it on a 20-year basis and a 100-year basis, and we zoom in on every single significant source. This is a steel plant that I'm using as an example in Ohio, in the United States, and we track it on a constant basis, all of these major sources. Google Earth has helped us with this particular style of video, but this is actually a computer graphic constructed from the video, and we can show you the emissions month by month, and actually the periodicity is coming down steadily, and we can show you exactly what's happening, whether they're going up or going down. Let's see, let's zoom out of that. Now, let's stay with that steel mill. This is the Gary Works steel mill. This is the thermal heat. We collect information in multiple wavelengths. This is the thermal infrared. Then the algorithms identify exactly where the heat and where the other where the plumes are coming. And we track them and we can characterize them. It makes it easier to follow this. We identify them, that we have the metadata on all of these sites. Now, let me use that same steel mill as an example to show you what we can find. This is the largest source of the greenhouse gas emissions. The climate crisis is a fossil fuel crisis. I mean, that's a major part by far. And you can see in the upper right-hand corner, you see that little notch? That's the pandemic. Let's zoom in on that. This is the first quarter of 2020 and the second quarter of 2020. So what did we see at that steel plant that I just showed you? This is the first quarter, this is the second quarter. And you can see what a difference it is. We see this all over the world, and we can track it month by month, really day by day. Now, one of the reasons why artificial intelligence is necessary is that you can track methane emissions from space directly. CO2 emissions, you cannot. Will and others will tell you, you can get, the newer satellites can get it from an area, but a specific point source, you can't, because the signal to noise ratio defies your ability to do it, because you're looking down through a column of air that is so enriched with CO2, with 414 parts per million, that it really makes it difficult. But with artificial intelligence, you can look at the smoke plumes, you can look at the infrared. I'll show you some other things that we look at as well. And artificial intelligence combines all of the information. And we have a different approach in each of the sectors. Here are a few example sectors for how we go about CAFOs and the rest. Here are vapor plumes measured with a Chinese satellite, the infrared with Landsat, the co-pollutants. We can also measure the aerosols, the co-pollutants that go with the greenhouse gas emissions, and you can actually derive the CO2 going backwards from them as well. We don't mainly do that. And how many cooling fans are operating at the same time? That's also a measure, and we can see that as well. In the first presentation that we gave at Sharm el-Sheikh last year, we had the 70,000 of the largest emission sites. The bottleneck is processing all this data. By the end of this year, we will have the 70 million largest sites. We could go, if this is all we did, we could go up to the multiple billions, but we're developing specialized user interfaces for the people who can have impact with this data, and I'll show you that in just a second. This is the website. I'm not going to go through the website live here, but you can do it yourself. You can go and see all of the largest emission sites worldwide. You can do it by category. You can do it by industry. You can do it by country. You can do it by region. Here's the Permian Basin. This is the single largest emission site in the world in Texas. Here's a New Mexico site in the Permian Basin. Oil and gas is the largest source overall. This is a confined animal feeding lot operation. This is the highway system in Houston, Texas, one of the airports in Houston, Texas. Here's another oil and gas field. There's the airport. This is a refining operation, Valero. And you can do this in every country, every region, as I say, every sector. And I invite you to go. It's all free. Just go to the website. Here it is, climatetrace.org. You can also download the data in multiple computer formats. Different researchers use different formats. We've got the ones that are most commonly used. We can tell you the top emitting assets in every country. These are the top 50 assets in China, top 50 assets in the United States, top 50 assets in India, top 50 assets in the European Union. These are by country. China, people are sometimes startled to see how much China's emissions have grown. And if you look back over the last several years, you'll see the steady increase. And here are the other countries by comparison over the last 7 years. So we've learned, for example, the largest sources are oil and gas, all of the top 14. Half of the top 50 polluting assets are oil and gas fields. We found last year that the self-reporting by oil and gas was half of what their real emissions were. Now we've included the flaring and the methane, and we found that actually the oil and gas operations are emitting 3 times as much as they are self-reporting. I'll show you what that looks like. This is what the oil and gas companies have reported. This is what they're actually emitting. Most sectors are not this far off. Oil and gas is unusual in this respect. And by the way, you just can't cheat on this because there's so many, it's impossible. When you use methane, methane's important, of course, because shorter lifetime, lower volumes, but each molecule has more than 80 times the heat trapping capacity as a molecule of CO2. So there's an increasing focus on methane, and we now have this global methane pledge. And so with the monitoring of the methane emissions, the nations that signed this pledge can be held to account for whether they are meeting it or not. We also do the same thing with different sectors. Steel, for example, I'll show you an example of how steel companies differ. Rice, we can get down to a 10 meter by 10 meter rice field. Shipping, I'll show you, we have virtually all major ships in the world. Power plants, we have all of the power plants. I can't tell you we have all of the landfills because some of them are very small. I can tell you we have 4 times as many as have been reported anywhere else, and all of these other sectors. Now here's an example of steel mills around the world. The height of these columns is not measuring the amount of steel produced. It's measuring the amount of CO2 and CO2 equivalent per ton of steel. So if you are if you have a business that's trying to get to net zero and you're buying steel, you can get the same quality steel from a company that has these emissions or one that has these emissions. And it's whether it's blast furnace or electric furnace or it has DRI or all the different technologies involved. So it makes a big difference. Here's an example, a comparison of a steel plant, a Nucor plant in the US, a Nippon East plant in Japan. Same quality steel, much more emissions from one than the other. A power station in Vietnam, a power station in Uzbekistan. And if you're trying to figure out where to get your electricity, you can make choices. Ships, we have virtually every ship in the entire world, not the little dinghies, but here's a comparison of 2 ships traveling the same distance, and the emissions are very much lower for this ship compared to this one. Maersk has pioneered the slow steaming procedure and many other technologies that reduce emissions and is now committed to net zero. Now, to conclude, the impact can come from, first of all, corporations that have made a net zero pledge. This gives them the chance to measure what they're trying to manage. Investors pledging net zero portfolios, they can find out how to do it. NGOs and activists trying to prioritize their campaigning, finance companies, journalists, researchers, and governments. And governments, this is really important because almost 80% of all the global emissions are from governments that have set a net zero target. So if their citizens and others want to hold them accountable, we give them the information to hold them accountable. Now, one of the reasons that this is important, there are existing inventories, and those of you who are specialists in this field will recognize a lot of these acronyms. All of them come mainly from a single bottleneck source, which is the self-reports filed with the United Nations. They're inaccurate, out of date. Developing countries don't have any of them. So we've relied on data that's not fit for purpose. One example, just before 3 weeks before the Paris conference, China said, hey, we want to alert you that our national reporting was all wrong, and good for them coming forward, but it's an example of how these self-reports are not fit for purpose, and the developing countries have not been given the resources to build this capacity. We can do it for them. The Enhanced Transparency Initiative requires developing countries to do it over the next few years. We can file the reports for them if they wish. We're also working, and we'll do it for any country that requests it, we're also working with subnational governments. We had a pilot program with 6, 2 in Mexico, 1 in Spain, 1 in Brazil, 1 in Italy, and 1 in the Western Cape. And we're going to take on any others who request it. To close with some optimistic news, we have all the technologies we need to reduce by half by 2030. We're developing the other technologies for the last half. And if we get to net zero, then temperatures will stop rising in as little as 2 to 3 years. And if we stay at net zero, then half of the human-caused CO2 will fall out of the atmosphere in as little as 25 to 30 years. In August of this year, we passed the biggest climate legislation of any nation in the history of the world in the US. 1 month later, the voters of Australia changed their government to a pro-climate government. 1 month later, Brazilian voters did the same. It illustrates the famous line from Wallace Stevens, after the final no, there comes a yes. And on that yes, the future world depends, and we can say to the young people who are demanding change that yes, we will change, we can change. Thank you very much. Look forward to your questions.
Great. As I said, thank you for the great presentation, also your leadership. Equally kind of the note of optimism. There are technologies. I think it's incredible to see what data technology can now provide, not only in terms of credible data, right? Not relying on sources that are maybe less than optimal because the capacity isn't there, but also the tools then to drive impact. So I'm just going to ask you one quick follow-up question, and then I'll invite those in the room to ask a question as well. What do you see as necessary to scale the use of this tool, the data that you have, to drive the impact and the outcomes? You gave us a number of examples. How do we drive implementation and impact?
Well, we are being besieged by folks who are asking similar questions, but there is a large multiple of those folks who are just going on their own to the website and using it already. I've run into a lot of people in the hallways this week who are saying, you know, we're using Climate Trace, it's making a difference in our operations. It will get steadily better and more comprehensive. And as I said, we'll go from 70,000 to 70 million. This year, we'll have the specialized user interfaces by the end of this year. And in the nature of the technology, machine learning algorithms get more and more accurate the more information that's provided. You know, GPT chat, everybody's heard of that, right? Just in the last 6 weeks, all of a sudden, wow. Yesterday I read that GPT chat just passed all 3 portions of the medical school licensing exam in the US. Not by much, but it passed. I mean, it's just crazy. I use that as an example of how artificial intelligence is steadily, isn't that amazing? yeah, kind of scary too. And all colleges and universities are trying to change their procedures to keep from, one of my granddaughters said, Granddad, the day it came out, all of my classmates started using GPT chat. It's really a major revolution. But the point of it is, artificial intelligence by its nature is one of these revolutionary changes that only comes along every so often. And here we have applied artificial intelligence in a process that is steadily improving, getting better and better and better and more accurate, and it fills a space that was completely open before. For the first time, we know exactly where the pollution is coming from. And as the world gets serious about reducing the greenhouse gas pollution, we know how to prioritize the reductions.
Absolutely. Questions? Take one here.
Hi, my name is Haris bin Saqib, and I'm from Pakistan, representing Global Shapers community. So first of all, thank you for the work you do and for this.
I'm sorry for what your country's been going through.
My question is that in past we have seen certain pledges and certain agreements where countries and corporations signed up for the action they will take to reduce carbon emissions. So now with this tool and now this data, in case in future we see that these corporations, they might sign up, but in future if they don't, so what control mechanism or accountability mechanism will be there to address this issue, and how will we manage this?
Yeah, great question. I'm not sure that I can give you an answer that's worthy of the quality of your question. By the way, thank you for going through the climate reality training program. We've had so many people from Pakistan going through it, and I'm so grateful for what you're doing. You know, I think that we are nearing a political and cultural tipping point where there will be a widespread demand from people in every country for corporations, companies that they patronize to get with the program. So I think you will see this get progressively easier to convince companies to get on board. It's hard, you know. Look, we get 80% of our global energy in this world from fossil fuels. It's not going to be easy, but we got to do it. We've got to do it. It's crazy, but keep on pushing. Keep on pushing.
We'll take two questions here. So one here and then another here, and then hand back to you, Mr. Gore.
Hello, Gore. My name is Thales Dantas. I'm also a global shaper, but from Brazil. Thank you very much for your presentation. I would just like to address the bottleneck that you showed us, which is the self-reporting system. And what do you think, how can that system change? Can we somehow leverage AI or any of these new technologies that we've been talking to not only have the data, but have this implemented in a new system so that we can rely on the reporting and not be faced by, as you showed us today, reporters that would change and they would just say that whatever was reported was actually not true, so that invalidates the whole conversation.
Yeah, well, your question is exactly the one that led us to establish Climate Trace. Climate Trace does replace, well, I don't want to say replace because I have such deep respect for the World Meteorological Organization and those in the UN system who have worked to try to make this self-reporting system function. It's difficult because, as I said, a lot of the nations don't have the ability to really draw up accurate reports to send into the UN. And the current system, only the rich developed countries are required to self-report. So it may be that the basic idea that nations self-reporting, and they get the data often from the polluters themselves, you know, and they have an incentive to underreport in some cases, many cases. So having an independent, multinational, nonprofit coalition that does this with artificial intelligence gives the world an opportunity to find out exactly where it is without having to rely on the self-reports.
One more question? Yeah. We only have time for one more, I'm afraid.
Hi, I'm Luana Janot, also from Brazil. I work with inclusion in the workplace, and I was also a trainer at the Climate Reality Project there.
Thank you.
Yeah, so I was...
We had 7,200 Brazilians sign up for the training 6 weeks before the election, and congratulations on your election.
Yes.
I met with Marina Silva yesterday.
Yeah.
Fantastic. Go ahead.
So, yeah, I was just curious. I mean, we are now engaged in the net zero, campaign, and hopefully we can get there. But I was also curious to get to know a little bit more from you. How can we engage with local partners around the world? Because, for example, there are a lot of indigenous communities in Brazil, Ecuador, but there are not enough companies partnering with indigenous communities who are already producing a lot of solutions for decades, for millenniums. So they are already engaging with hydrogen, they are engaging on, planting the trees, but they are not partnering with companies. So I would like to know how can climate, the platform can help to encourage more companies to work with those local partners who already have the solutions for our problems.
Okay, if you are from, we have had a lot of trainees in Brazil working on the local, on the provincial, regional government laws. If you are in a particular city in Brazil, or a particular province, you can go there, you can go to Climate Trace and identify the largest source of greenhouse gas emissions in your city. in the region where you live. And then prioritize your activities according to where you're going to get the biggest results for the effort that you put into it. That's part of what I hope happens on this. There is a longer range plan with Climate Trace. I've worked with some friends who are mapping out a project to develop what are called OKRs for each of the individual large polluting sources. How can we come up with a plan to transition them to a less polluting technology, protect the employment, protect the community, have a just transition, but find a pathway to get away from the most polluting sources and toward an alternative that has less pollution. And when we get this up and going, it will be available to people in every single region and every single community in Brazil and elsewhere. That's our dream.
All right. Thank you, Mr. Gore.
Thank you all for coming. I
the
appreciate it very
presentation.
much. Thank you.
Thank you for your leadership. And thank you for watching.